The purpose of this video is to provide you with some guidance and assistance with preparing your flowchart for the Experiment 2 procedure. Experiment 2's procedure lends itself very well to a nice, structured, organized flowchart, and there's some techniques that you can use to organize the procedure into a nice, coherent flowchart. So I'm going to give you some assistance with that. So the flowchart goes through the entire procedure, but rather than putting it in a linear, stepwise numbered set of instructions, it's not necessarily linear, but it does organize all of the steps of the procedure. And then it also helps you to organize the outcomes of those steps. So the flowchart should really help you to understand the procedure a bit better. So that's what we're going to try to do with our flowchart now. So I'm going to start my flowchart where the procedure starts, which is with those three components of my mixture. And I'm going to use circles to represent sort of the components of the mixture, the states that they're in, and then I'll use boxes to represent the actions that we're going to take to separate those components. So you'll see me using circles to represent the chemical compounds and where they currently are in our procedure, and boxes to represent the actions that we're doing, like filtration or decanting or adding a reagent, that type of thing. So my initial mixture contains my three solids, my sodium chloride solid, my calcium carbonate, also solid, and my silicon dioxide solid. And I'm going to make a note next to my initial mixture that I need to record the mass of this mixture. Something that I like to do in my experimental flowcharts is to make a note of each instance where I need to record data, just so that I don't forget. So the mass of our mixture we'll need in order to calculate the mass percent later on. So this mass here of the solid as a whole is going to be the denominator in all of your mass percent calculations. So what we need to be able to collect from our experimental procedure is the mass of the sodium chloride, the mass of the silicon dioxide, and the mass of the calcium carbonate that's present in our mixture, so that we can divide it by the total mass to calculate the mass percent. So we'll do that later, but this is where the mixture starts. And so in order to separate the components of the mixture, I'm going to go through my procedure and see what steps I'm performing. The first step that I see is that I'm adding water. So I'm adding water to the mixture. And I want to make a note of what happens when I do that. And so how do we know what happens to each of the components of the mixture? Well, you're going to use that table of physical properties that you prepared by watching the video to see what happens when you add water to sodium chloride, what happens when you add water to calcium carbonate, and what happens when you add water to silicon dioxide. And so from that video, we saw that the sodium chloride is the only substance that's soluble in the water. So this sodium chloride is going to dissolve. So the sodium chloride dissolves, and the calcium carbonate and the silicon dioxide remains solid. And this technique, where we add water to specifically dissolve one component of a mixture of solids, this technique here is called an extraction. So specifically a solid liquid extraction. So I'm just going to make a note that adding water to selectively dissolve the sodium chloride is an extraction. So that's my first step of my procedure. And so now I can continue on with my flowchart. I can't branch my flowchart yet because adding water doesn't separate the components of the mixture, right? They're still all in the same beaker. We just now have sodium chloride dissolved, and the calcium carbonate and silicon dioxide are still solid. So in order to actually separate these components, there is another step, and that step is the gravity filtration. So the gravity filtration that we perform is going to take the sodium chloride that's aqueous now, so the aqueous dissolved sodium chloride will be separated from the solid calcium carbonate and the solid silicon dioxide. So that gravity filtration step now allows me to branch my flow chart. So I'm going to branch my flow chart. And the branches that I create are indicating now that those components of the mixture are in separate spots. So I've separated the solid, I've separated the aqueous sodium chloride from the solid silicon dioxide, which is combined with the solid calcium carbonate. So these two things are still solid in solution. The sodium chloride is aqueous, the silicon dioxide and calcium carbonate are solid, but now they're in two separate spots. So we started with this initial mixture, we recorded the mass, we added water to dissolve the sodium chloride, the calcium carbonate and silicon dioxide remained solid. So that was an extraction, a solid liquid extraction specifically. Then we used gravity filtration to separate the aqueous sodium chloride from the solid calcium carbonate and the solid silicon dioxide. At that point, we have the sodium chloride solution in one container, and we have the silicon dioxide and calcium carbonate in another container. So at this point, there's a few more steps on the sodium chloride side and a lot more steps on the silicon dioxide calcium carbonate side. So our flowchart's not done. This is just the start. So the sodium chloride is aqueous right now. Aqueous means that we have this mixed or dissolved, rather, dissolved is a better word there. The aqueous means that this is dissolved in water. So I need to remove that water in order to get the mass of the solid sodium chloride. So there's another action that has to go here, and I'll leave that to you to fill in what that action is until we can get the solid sodium chloride. So the solid sodium chloride is our end result. This is what we want. And this is what I'm going to record the mass of the solid sodium chloride. And I'll use that mass in a calculation for the mass percent, right? Because I need that mass. The mass percent of sodium chloride in the solution is going to be equal to the mass of the NaCl over the total mass of the mixture times 100. So the mass of the solid sodium chloride we'll measure here. The total mass, remember, we measured at the beginning. So that's how we'll do our calculation to get that mass percent. And that's why we need to record that mass. So you'll fill in what action we're going to use to separate the aqueous solution of sodium chloride, the sodium chloride that's dissolved rather, from the water that it's dissolved in. So we've got to remove that water. And you'll fill that spot in the flow chart here. So the other side of our reaction is a little bit more complicated. So we've got to do a little bit of work to separate the silicon dioxide from the calcium carbonate. So if you're continuing on through the procedure, looking at the procedure, the next step, or what we're going to do to this mixture of these two solids, we're going to add hydrochloric acid. So we're adding HCl, hydrochloric acid. And remember, in your notes, you want to make a note of what each chemical formula means, what the name is, HCl being hydrochloric acid, all of those things, so that you can grab the correct chemicals from the fume hoods. So when I add HCl, just like up top, I wrote what happened when I added water. When I added water, sodium chloride dissolved. The other two things did not dissolve. When I add HCl, one of the components of this reaction will react and one will not. So how do we know which one reacts? Well, that was, again, information that we can get from our table of physical and chemical properties. So you recorded observations of what happens when you add HCl to silicon dioxide and what happens when you add HCl to calcium carbonate. So we should know which of these components is going to react and which will not based on those observations. So when we add HCl, one of our substances will react. So one of our substances reacts And I'll just let you know for this one. So the calcium carbonate reacts with the HCl. The silicon dioxide does not react. That's important information. We add HCl and the calcium carbonate reacts with HCl. The silicon dioxide does not react. And what we want to be able to understand is what this chemical reaction looks like. And at this point in your chemistry classes, you probably haven't gotten to this type of chemical reaction just yet, but that's where doing a little bit of Googling can be helpful. So what you can do is look up what happens when we mix calcium carbonate, which is a solid, right? Solid, with aqueous 6 molar HCl. What are the products of this chemical reaction? And the products of this reaction are what we're making use of in this separation. So we've got solid calcium carbonate. We react this with HCl. And the products of this reaction, and again, you can Google this. This is where doing a little bit of legwork before lab is helpful. What we're going to form is this calcium is going to combine with the chloride in order to make calcium chloride. I'm going to use a lowercase l so that it doesn't look like an I. CaCl2, calcium chloride, and that is aqueous. Aqueous meaning soluble. So by reacting calcium carbonate with hydrochloric acid, what we make is calcium chloride, which is soluble. So there's other products of this reaction as well that you'll observe forming. So carbon dioxide gas, you'll be able to observe that forming, and you should record your observations as you're going through the experiment. And there will also be water formed as a product of this reaction. You won't be able to see the water, but it's one of the products of the reaction. So forming this aqueous calcium chloride, that's why we do this chemical reaction. So that chemical reaction occurs. So after we add HCl, now we have calcium chloride, which is aqueous, meaning it's dissolved in water. So we've dissolved the calcium that's present in the solution by converting it to calcium chloride. And we can separate that from the solid silicon dioxide. And we're going to use one of our separation techniques here through decanting. So we're going to decant the calcium chloride solution, which will be a supernatant. It's going to be dissolved. We're going to separate that dissolved calcium chloride from the solid silicon dioxide by decanting. And that allows us to, again, branch our flow chart because we're trying to get each of the components of our mixture completely isolated. So now that we've done this next step through this chemical reaction, we have silicon dioxide, solid, but there's also going to be just a little bit of water present in that, plus a small amount of water. And again, there's going to be a step that you'll do to remove that water. So how are we going to remove that water to eventually get to dry silicon dioxide that is solid? So I'll leave that again to you to fill in. And you want to have a complete flow chart when you come to lab. So do fill that in. So after we're able to remove that water from the silicon dioxide, now we are going to weigh the silicon dioxide that's solid and record the mass. So once we have the dry silicon dioxide, we're recording that mass, and we are done with 2 of the components of our mixture. So heading back over here, we have this calcium chloride that is aqueous in solution, right? That's what we decanted off of the top of our solution after we added HCl. So we have aqueous calcium chloride that we now need to convert back into calcium carbonate. So that's going to be another chemical reaction here. So again, going through your procedure, we are going to add something. So we're adding, and I'll just let you know here, we're adding sodium carbonate, and that's an aqueous solution. We're adding a solution of sodium carbonate. And when we do that, there's going to be another chemical reaction. So we're adding we're adding sodium carbonate to instigate a chemical reaction. And here, I'm going to leave this to you to search. Look up what happens when you mix calcium chloride, aqueous, plus sodium carbonate. Again, also aqueous. What are the products of this reaction? And specifically, what are the states of those products? So there's going to be two products of the reaction. One is going to be solid. One is going to be aqueous. And I apologize for the barking. My neighbor's dog is a little bit rambunctious. So we have solid and an aqueous product. And we are going to use the fact that now we've created a solid product in order to separate, once again, the components of this mixture. So use some Google searching to figure out what the products of that reaction are. And then we are going to perform another step, so another separation. That separation will allow us to isolate the calcium carbonate that's solid. And eventually, what we'll have here at the end is solid calcium carbonate. So I'll leave that to you to fill in those remaining steps of the flow chart there, using the procedure video. And the last thing that we've got to record here is we're going to record the mass of the CaCO3, which will be a nice dry solid. So this is kind of how my overall flow chart looks. And you'll see it's kind of long. This might end up needing to be something that you fit on multiple pages. But when you read through this, now we can see what happens to each component of the mixture as we go through. So we start with all three as a solid. We're going to add water to selectively dissolve the sodium chloride, which will leave behind the solid silicon dioxide and the solid calcium carbonate. We separate the solids from our aqueous solution using a gravity filtration, which then gives us our solids on one half and our aqueous solution on the other half, separated in different containers. And so we represent that separation by branching our flow chart. So my sodium chloride still has water in it. So I've got to do some other step here to get rid of that water to get the dry sodium chloride. And then I'm going to record the mass of that dry sodium chloride and calculate the mass percent. On the other side, to separate the solid silicon dioxide from the solid calcium carbonate, I'm going to add hydrochloric acid to perform this chemical reaction, which converts my solid calcium carbonate into something aqueous. So by chemically reacting the solid calcium carbonate to turn it into aqueous or soluble calcium chloride, that allows me to decant, to separate the now dissolved calcium chloride from the solid silicon dioxide. And so that gives me my solid silicon dioxide in one container and my aqueous calcium chloride in a separate container. So this solid silicon dioxide will be slightly wet, so we're going to do something to get rid of that water again. And then we'll have the dry silicon dioxide. That dry silicon dioxide will measure the mass and use it to calculate the mass percent. So the calcium chloride that's aqueous, I've got to convert back into calcium carbonate. We do that by adding sodium carbonate. So again, that's a chemical reaction. You're going to want to look up what the products of this reaction are. And then after that chemical reaction, we're going to do some additional separation. Again, that's described in the procedure. And that will allow you to isolate the solid calcium carbonate. And you're going to record the mass of that solid calcium carbonate and use that to calculate your mass percent. So the flowcharts are really a nice, helpful way to organize your thoughts about the experiment so that you can understand what you're doing at each step and why. So in addition to this flowchart, each of these separation methods that you're going to use, so you're going to use decanting, you're going to use a gravity filtration, you're going to use a vacuum filtration, and you also use solid liquid extraction. You want to make sure that you know what each of these techniques looks like, especially the gravity filtration and the vacuum filtration. There's a lot of equipment involved in those two things. And because those are standard techniques, that equipment and that setup is not listed specifically in your procedure, although it is demonstrated in the procedure video. So what I would do is I would create sketches of this. So sketch the setup and make a note of all the glassware that's involved so that when you need to set up a gravity filtration and a vacuum filtration, you can do that. And if you have all of these things in your lab notebook, you're going to be set to just cruise right along in the experiment, and you'll have a very good understanding of what you did, why you did it, why each step was performed, and that'll make completing your post-lab questions a lot more straightforward. And it'll also make sure that you really do understand the concepts that we're trying to understand in this experiment: physical separations, chemical separations, and all of the learning objectives that we want you to accomplish from this experiment. So I hope you found this video helpful in preparing your flowchart. Make sure that you include as much detail as possible in your lab notebook as you submit it for your pre-lab notebook.